Hello everyone, this is Ma'am Amano, and this lecture video is all about the mirror equation. From our previous reporters, we have known that the mirror equation can be expressed mathematically as 1 over f, or 1 over the focal length, is equivalent to the 1 over the distance of the object, plus 1 over the distance of the image. So those letters are in subscript form, alright? So for sample problem number 1, we have here an object 4 cm high is placed 8 cm from a concave mirror whose focal length is 5 cm. Letter A, what is the location of the image? And then letter B, what is the size of the image? So you have the following given values from the problem. You have here the size of the object at 4 centimeters here, based here, and then the distance of the object at 8 cm based on the placement in the concave mirror, and the focal length is 5 cm. Then you're asked to find the distance of the image based on this problem, the location of the image, and then the size of the image, which is S sub I. Now to solve problem A here, we will be deriving from the mirror equation of 1 over f is equals to 1 over the distance of the object plus 1 over the distance of the image. All you need to do is substitution. So you will have here 1 over f, which is the value of focal length is 5 cm, and then 1 over the distance of the object, which is 8 cm here, and then 1 over the distance of the image, which has no value yet. So the next thing that you need to do is to rearrange the equation in such a way that you will be able to obtain your desired value or reference for the value, which is the 1 over the di. So you will have to equate that into another form. So you will have here 1 over d sub I, or distance of the image, is equivalent to the 1 over 5 cm minus, because you rearrange the equation, 1 over 8 cm. And then the next thing you need to do is find the LCD, or least common denominator, of 5 cm and 8 cm. All you need to do is skip count and then get the common least denominator of that. You have 5, 10, 15 until 40, and then 8 until 40. Then you will have here the 40. And then you will write that here, 1 over di is equivalent to the over 40 cm squared, that will be expressed in squared 9 denominator. Then 40 cm squared divided by 5 cm will be 8 cm times 1, that will become 8 cm here. And then 40 cm squared divided by 8 cm, that will become 5 cm times 1 here, the numerator, that will become 5 cm here. So the next thing that you need to do is 8 cm minus 5 cm, that will become 3 cm over 40 cm squared. And then the next thing that you need to do is cross multiply for you to obtain the value for the distance of the image. So you will have here distance of the image multiplied to 3 cm. You will have 3 cm, and then the distance of the image is equals to the 40 cm squared times 1, which is 40 cm squared. Then divide both sides by 3 cm, so you can cancel out the cm, and then you will have the left distance of the image. So you will be able to cancel here, this one cancel, and then 40 cm squared divided by 3 cm, that will become 13.3 cm. So the distance of the image is 13.3 centimeter. Now for solution B, you are being asked to find the size of the image. To find the size of the image, you will be using this magnification formula for the equation, which is size of the image over the size of the object is equivalent to the negative value of the distance of the image over the distance of the object. So this one is constant, the negative inversion of the distance of the image to denote the inverted image. So that is constant, both in convex and in concave. And then you will have here SI, then substitute the value of your size of the object is 4 cm based here, equals to the negative 13.3 cm, which is your negative, times the value of your distance of the image, which is 13.3 cm, and then over the distance of the object, which is 8 cm, then cross multiply so that you can have the SI, or size of the image, which will yield the value for that. So you will have here SI, or size of the image, the variable, multiplied to 8 cm, you will have 8 cm SI. And then the next thing is 4 cm times negative 13.3 cm, you will have negative 53.2 centimeters squared. Then divide both sides by 8 centimeters, so you can cancel this one here, and then you will be left out with the size image variable. And then divide both sides by 8 cm, so you will be able to cancel this one, and then you will have here negative 53.2 cm squared over 8 cm. Therefore, size of the image, dividing that, will yield to negative, this one is negative, I'm sorry for this is negative, negative 6.65 cm. The answer here. So this is negative 6.65 centimeter. And then sample problem number 2, an object 12 cm high is placed 15 cm from convex mirror whose focal length is 14 cm. Letter A, what is the location of the image? Letter B, what is the size of the image? So you have here your size of the object at 12 cm, you're given 1. And then you have the distance of the object, which is 15 cm. And then the focal length is 14 cm. Those are your given values here. And then you are being asked to find again the distance of the image for the location of the image. And then for letter B, you are being asked to find the size of the image. Now, to solve for solution A or problem A, you will be using again the mirror equation. Substitution, 1 over focal length, which is 14 cm, 1 over 14 cm. And then the value of your distance of the object is 15 cm here. And then the value of that distance image, you don't have a value for that. So you have to rearrange the equation in such a way you will be able to obtain the variable di. Okay, so the next thing that you need to do is 1 over di is equals to the 1 over 14 cm minus 1 over 15 cm. You will have a negative value here since you rearrange the equation. Then the next thing that you need to do is find the LCD. That will be 210. And then write 210 centimeters squared at the denominator. That will have to be cm squared for you to be able to have the unit of cm since you are being asked to find the location or distance. Then 210 cm squared divided by 14 times 1 will be 15 cm minus, and then 210 cm squared divided by 15 cm, that will be 14 cm times 1, that will become 14 cm here. And then 15 cm minus 14 cm, that will be 1 cm over 210 cm squared. And then you have to cross multiply so that you can obtain the variable for distance of the image. So you will have here the distance of the image, the variable, multiplied to 1 cm di equals 210 cm squared times 1, that will become 210 cm squared here. Then divide both sides by 1 cm so that you can have the di variable. And then you will be able to cancel the 1 cm and then divide 210 cm squared divided by 1 cm, law of exponent, you will be able to have 210 cm. Okay, and that is the distance of your image for letter A. Now for letter B, you will have here the following solutions. Okay, so you will have the magnification formula, which is the size of the image over the size of the object is equivalent to the negative value of the distance of the image over the distance of the object. And then you will have here the size of the image over the size of the object, which is 12 cm, and then the negative value of the distance of the image, which is here it is positive times the negative, that will become negative 210 cm over the value of the distance of the object, which is 15 cm. Then cross multiply so that you can have the SI variable. So you will have here 15 cm multiplied to SI, that will become 15 cm SI, is equivalent to negative 210 times 12 cm, which is negative 2520 centimeters squared. Then divide both sides by 15 cm so that you can cancel that out and you will be left out with the SI variable. And then cancel. Then you will have negative 2520 cm squared divided by 15 cm. You will have the size of the image, which is 168 centimeter. So that is the answer for sample problem number 2. Now for your take-home assignment, I want you to submit this on Saturday, this week as well. Of course, you will have to submit in terms of solution sheet. Alright? So that is all for this lecture video on mirror equation.